Welcome to Team 15's automated ultrasonic inspection device. Storage tank containers are necessary for storing process resources. As a result, they are subject to various levels of corrosion. The sections in red illustrate areas of pitting corrosion on the underside of the tank, which are commonly caused by soil abrasions and trapped moisture. Before inspectors can enter the tank, the stored material is transferred to a separate container. Inspectors then enter the tank to commence scanning. Upon entering the tank, operators are unable to visually see any pitting corrosion on the other side. The red circles illustrate locations of corrosion as shown previously. To combat this, operators introduce a device known as magnetic flux leakage, or MFL. The MFL operates using a constant magnetic field. Any pitting causes disruptions to this field, which allows the MFL to identify the locations of corrosion on the underside. From this point, the MFL scanner continues along the entirety of the tank floor, highlighting any locations with pitting corrosion. One limitation of MFL scanning is that it is incapable of providing quantitative data. Therefore, we must introduce another process known as ultrasonic testing. Here is a close-up of a single highlighted plate. As mentioned, the corrosion seen here is not visible to the operator. To combat this, we introduce ultrasonic testing. A small probe is used to transmit high-frequency sound waves into the material. As the sound wave permeates through the material, the time of travel is recorded and used to calculate the material thickness directly beneath the probe. By moving the probe directly above a pit, we can see that the time of travel is significantly reduced. This reflects a lower level of material thickness underneath the probe. The current implementation of this process, however, is slow and tedious. An operator is required to move the probe by hand. This is undesirable as it is prone to human error and does not provide a solid means of recording the collected data. As a result, there is a need for a device that can minimize errors and reduce inspection times. Here we have an operator scanning a sample material by hand. To increase efficiency and productivity, our team has developed the automated ultrasonic inspection device for pitting inspections. The device was created to help provide operators with a more efficient process while minimizing errors compared to the current implementation. Equipped with a microcomputer and graphical user interface, the device allows operators to customize the scanning parameters. The use of off-shelf components acts to reduce cost and to make maintenance practices shorter to minimize downtime. By combining two types of stepper motors, our device is capable of creating a serpentine path for the scanning probe. This ensures that the entire plate is scanned without missing any potential pits. Here is a video of the automated ultrasonic inspection device in working function. Using the graphical interface, the scanning dimensions were customized to measure half the plate width. During this time, the measured thickness values are recorded in the microcomputer. The data stored in the microcomputer is then used to populate a visual heat map that can illustrate areas of risk. Here is a sample of a heat map containing 3 pits. Green represents nominal thickness, yellow shows minor loss, and red represents areas of major concern. Using the top view, operators can easily locate the position of the pits and assign the necessary repairs according to regulation standards. Here are some key highlights of our device. The use of 3 or more devices reduces inspection times. It is accurate enough to meet commonly used standards and is capable of managing field conditions. Additionally, it is compatible with a variety of ultrasonic equipment and can be built for approximately $1,200, which is a drastic reduction versus purchasing pre-existing equipment. Special thanks to NextGen Industrial Services for sponsoring this capstone. On behalf of Team 15, thanks for watching.